Alright, we are starting webinar Precast Concrete Modeling and Documentation in Revit. My name is Valensas Balsevičius. I was structural engineer. Now I work as BIM application engineer in AGACAD. And we create applications for Autodesk Revit based on web needs of BIM practitioners. And we eliminate tasks which do not create value. So we create very big, wide range of solutions. We have wood framing, metal framing, tools for MEP guys, and then precast concrete, which I will talk to today. Okay, and we are industry partners with Autodesk for precast concrete. So we are really proud to be partners with Autodesk, and what we will cover in this webinar, we'll create precast elements, create connections, reinforcement, and create shop drawings. So basically that's to summarize this over here, some information about it. And I will also talk about new tool which is called Floor+C, and we will release it next week. This is to create slabs. So to get this tool, existing users, they will need to update tools for BIMDoc and then activate precast concrete with a license code which you already have. And for new users, it's just you will have to install this tools for BIMDoc, which I will show you a little bit later, and get the trial code, and you're good to go. All right, so this is it. Let's switch to Revit. This is my Revit screen. I will use it to show you how to model precast elements in Revit. Okay, so here you have some walls already modeled, columns and beams by using standard Revit commands, what's available in Structure tab, like to draw beam, wall or column or floor. You can use these tools to build up model like this. Then I place some doors and windows over here, and then I'll get to precast concrete, and you see here tools for BIMDoc, and you can download it from our webpage and get the trials, install any of our tools. So first of all, I will start from Smart Walls tool, what I have here. And this tool allows us to split single wall like this one into wall panels. To draw such a long wall is very easy, but when you need to split it with some gaps, so it's easier to do with this tool. We have some settings for splitting, how to split around openings, how to split with intersections, other elements as well. So I'm gonna use that. First of all, I have here wall with some openings. I will use this command to split in the center between openings. So it will find all the openings and it will split just in the center between them. So that's one of the ways, right? Then I will use other commands, like I have for the individual commands. I can use grid lines to split that. I can use other walls. For example, I'll do it like this. So now I define what should be the distance in the settings, and then I get this split from that location. Then I can select walls and use any of these commands, like split from both ends, right? So it will just split by defined distance. I define that 2.5 meters should be my panel size. So now it's just splitting to meet these requirements. It's 2.5 meters, as you can see it here. And one panel is different size because there was just not enough space. But yeah, let's split more of these. Let's say I can just click on that, right? By maximum space. So again, it's just trying to fit into some settings what I have, and split my panels into just defined way. So that's what I will do now. split a couple of more. If you, for example, you want to you don't want to have this kind of panel, you can join them and you can modify them again, split with grid lines or other options, or just in half. So again, any of the commands could be used here, right? So I'm working with walls just to get separate panels and some gap distance, and then later on I will create connections between them with another tool. So now I have walls, I'm pretty happy about it, and I will use now another tool which is called Floor Panel Layout. So there was a question if you can split by panel weight. So there's no such option, but I guess you know the thickness and you know approximately what should be the width and length of the panels. So usually it's not a problem. Then we have Floor Panel Layout, one of the tools to create floors. So I will add supports to my floors. You see I have one floor here, another one here, and another one here. So what I will do, I'll select this floor and I will say that this is my support for the slab, this is my support for the slab, this is my support for the slab, and this one is my support for the slabs. And the tool will remember that. You see I clicked on show supports, so it now knows what elements will be used for support of my slabs. So next step would be to create layout of the slabs. So you have here settings, what should be the slab size, what should be the layout direction, and then you just can click on the slab and it will create these lines. Based on these lines we will create actual slabs, but well, you see these slabs now are created, and then you can create use other options again to modify them. So I just join them, then I can say I want to have, let's say, 100 millimeter over here, and maybe from here to here again the same distance, just to split them in such a way, or just distribute and change in any way you like. For this slab I will do the same. So now I have layout over here of the slab, so I can align them, modify, update, and so on, right? So next thing, what I will do, I'll create actual slabs. So I'll go to create panels, and here I have settings. What should be the slab size, what should be the cut for the slab, what should be level offset, what should be supports, how much it should be supported on walls, on framing elements, or grid lines also could be used as a support element. So I will create panels now for the floor, and you'll see now floors will be created here for all the defined layout. Some analytical model was disrupted in some areas. Not a problem here, but oh, so I created slab over here as well. So I should have maybe used that for them only for the floor face. But now what I have here is my hollow core slabs with some cutout. This cutout, it could be a different family. For example, if I select that, you will see that this is sweep shape. You can define what should be, just draw the lines and define what should be the shape of the slab. Yeah, and depends what kind of settings do I use. My slab will be like that, right? For example, I'm gonna change this to another one. So I'll do that and do this for the face this time. Like that. And the size of this floor, which is not standard size, it will be different floor type without holes, but later on you can modify it or insert additional cuts if you have a family what you need. Okay, so these are two different slabs created, but what I have used here was floor elements. So if I select that, you see this is floor and it's cutted with my family. Now if I'll go to level 2 maybe, and we can take a look here, how does it look in the section. So we'll see that this one, in another direction, I selected the supports. So you will see that my slab is automatically 80 millimeters supported on this wall, and on this beam it's supported by 120. So it comes as well from my settings automatically. I don't need to modify that. So this is one of the ways to create slabs, but as well we can use another tool which as I mentioned previously, it's Floor+C. This tool allows us, it has configuration window, and in configuration window we have different flooring. We can select what type of structural framing do we want to create. So in this case we will use structural framing, so we can use any structural framing family and we can distribute it in defined direction with defined spacing and so on. So for example, what I will do now, I'll select this one and this floor, and then it has 2 layers, and I will say that in this layer I want to place this family. Okay, so I'll do that, and then by that configuration, and then I will place these families. So we'll see I'm just now creating layout of structural framing elements. They are disallowed joints, so you don't need to do that manually. Then the last piece is automatically smaller, but again I can do some kind of modifications. For example, I want to have a different size maybe. Yeah, we'll change this just to make it more clear visually what was changed. So I have quite a lot of tools to modify and to change that. So you see I added 2 elements at this edge, then this piece is moved a little bit further. So in this way I can make layout of the slabs. Maybe I'll switch to the full view and you will see 2 additional slabs here what I have created. And this tool comes with some default configurations for double T slab, hollow core slab, and solid slabs. So now I'll change to another configuration. So I want to use double T slabs over here. And then these families of structural framing elements, it comes with a software as well, but you can use families from Revit or whatever you have if you use structural framing families for the slab layout. So I had also some cuts over here, this one and this one, so they are automatically cut. My elements are divided over here. The edges also are cut, and so on. So this is structural framing families, right? And then the floor panel layout, it also works great with different shapes and cutouts. So I want to show you another option. I'm gonna pick this different cutout family as well, and I'm gonna save it and then create panels over here and then do that based on this layout and these cutouts and so on. So again, I have floors separated, they have all the cutouts what I need here. It's following also the shape of the floor, not only the cutouts like a family cutouts. So it's pretty cool. You can do that whatever here. Then we have another tool which to place connections and create elements, right? So maybe I'll go back to this view as well again. Sorry. Over here, and what I will do, I will just filter out walls, and we will just take a look. So isolate elements. It will be a little bit clear to see. So we have another tool in Precast Concrete. We have Smart Connections, and Smart Connections has configuration window where you can define configurations. You can save them under different names, and you can insert line-based or point-based families on different faces of elements. And you can use it with different categories, with walls, framing elements, columns, and so on. And it could be used for steel, concrete, or wood structures. Because it will distribute Revit families, whatever you have, like face-based families or line-based families, on selected elements. So what I want to show you, maybe I'll just select a couple of these. And what I will do, I'll go here to create, insert elements, and I'll pick the configuration which I want and click on insert. So it will go through all 23 walls and insert all the connections which I defined in my configurations. In configurations I defined different searching options, so it will find connections between wall elements, and based on that it will place some elements. So it's let's wait a few more seconds until it will finish with all the panels. Alright, so we have these tubes at the bottom, these elements at the top. Then we have these connection loops, and we have this cutout family, which is here, placed to cut the ends of my wall. And if I move here a little bit, you'll see that this panel, it has only loops at the ends, but this one has additional loop over here. And the reason for that, because in Smart Connections, in configuration, I can search for connections with other walls and only then place a selected family. Families, whatever you create, or you can use some families from the sample project, which is available in the help section. And you have to have these families in your project, so to make them use it with Smart Connections. In the corner, for example, I have another rule. If it's corner, I place this kind of cutout. So it can do that automatically. I don't need to do that for each single panel. And because these are Revit families, face-based families, it's not a problem to modify them later on if needed, right? You have modify options, like modify, for example, and say, I want to make it, for example, like that, and click on update. And all of these now moved a little bit to the top, right? Maybe I want to have some gap to make it precise modeling. And then I want to, this element was not inserted here because I have opening. So I can just simply move it, create another copy, right? And just control where the new element should be. So it's you don't need to insert it at the bottom and adjust it to both directions. You just insert, then copy, move it, and get the result you need. So that's one of the example, but it could be used in many different ways. I have other walls here, for example, different connections, right? Corbels are placed at the bottom of double T. Double T has these cutouts, so it's also placed with Smart Connections. These, of course, plates are placed as well automatically. Then I can say that, for example, I have these structural framing elements, structural framing. So I'll just isolate them and insert elements. And then I'll pick from the configurations what I have. So actually it's not okay. Let's use it on the other elements. I don't have that configuration which I wanted to show you, so I will better show this on these elements maybe. So it's also okay. So we have here inverted elements, so I'll insert elements to these guys and then insert, and that's what I get automatically, right? These are placed by gravity point because the tool can calculate the gravity point of your elements, then some holes for anchoring, some holes for fixing to the column, right? So I can do that as well, and column as well, not a problem to insert it. Some connections, so I'm just gonna isolate this one again, insert elements. Yeah, this configuration is okay, so I'm gonna drop these guys. Yeah, so that's one of a couple of other examples how to use this tool. Then we have some reinforcement tool, right? So I'm gonna go back to this view, and for reinforcement we have two tools. We have wall reinforcement and beam reinforcement. So we have configurations, how to what kind of external, internal reinforcement should be, opening reinforcement, perimeter reinforcement, and then we can define also a couple of settings, how to make them solid, to group them, and so on. And then you have wall. You say link configuration to that wall layer. So again, if we have a couple of layers, for each layer we can define different configuration if we want, right? So for that wall, I assigned this configuration, and then I can select that type of wall, and then go to create and create rebar. And it will create reinforcement for all selected panels. Again, based on the shape, it will analyze the shape of reinforcement and place reinforcement which I have defined. So I have now these groups of rebars created. I have diagonal bars at the edge of the perimeter cuts. This is window reinforcement, right? So I made this kind of connections, and I have these U-shaped bars going along perimeter. Again, you can modify everything quite simply. For example, modify rebar, and I don't know, we can just, let's say, make it 0, save it, and then this element in the corner was removed. Or another possibility is that this cut is made with this family, and that's why the tool is reinforcing at it as an opening. But if I add some special parameter in this family, then I can use new option which we included last week in the update. So you can select to exclude inserts, so it will ignore this family cut, and it will just go through it. This is quite big cut, so of course you want to probably cut your reinforcement, but sometimes you have just small cuts which is coming with a detail, like inside the detail you have some kind of cut, and you don't want to take this into account, so you can do that with that option. So this is wall reinforcement, but in a similar way you can do that with beam reinforcement. So I'm just gonna undo that. Sorry. Maybe we'll just cut out this, guys. So alright, maybe it's even better to isolate it as a single element. We'll go to rebar configuration for the beams. So for the beams we have 3 different shapes: rectangular, L shape and IT shape. And then we define covers, we define main elements, we define stirrups, what kind of stirrups should be created, how it should be distributed, and so on. And then again, we link this configuration to selected wall type, beam type, and then we create rebar. And what's happened now is that I have distributed these stirrups. I made 2 in the beginning, and then I start stirrup from here, right? So for each end I have these 2, and then the line of other stirrups, and the same like that, and then some main reinforcement at the top, at the bottom, at the side faces of the structural framing element. Okay, I'm gonna remove this section box, and then next step would be to renumber them. So we have here, let's go to level 1. We have all the walls here. If I will annotate these walls by tag, so it's giving me question mark. It means that no mark parameter is assigned. So if I enter something here, it will be available. But now what I will do, I will select all of these walls, go to sort mark tool, renumber elements, mark, and click on OK. And then I have settings here for filtering, grouping, numbering, sorting options, and then the final configuration, how the mark should be created. I will click on OK. It will renumber all of these elements. And now I have these mark values, right? So over here, over here, over here as well. So all of them are renumbered. And now we can start creating shop drawings. So for that, I will select this wall, go to Smart Assemblies, then I have configurations, for the shop drawings. So I define the views, how many views do I want, direction, name of a view, view templates, and dimension rules. In dimension rules I define how elements should be dimensioned, details, cutouts, reinforcement, what kind of nodes should be created, and how they should be placed. Then what kind of schedule should be created, and sheets. So any number of sheets or schedules as well could be created. Then I select this element and go to create modify, and I have commands to create, update, and modify assemblies. I'll pick on configuration which I want to use and click on create. So it will add all hosted elements, reinforcement, and details into assembly. It will create views and dimensions. Also, it is calculating assembly mass and inserting gravity point. So you see I selected only wall, but all the elements are included automatically into assembly. I will go down and find this assembly in my project browser. So it created 3D view for me without reinforcement because I have used some visibility settings. Then I have front view, and I have here spot elevation at the top and bottom. Then I have dimension lines for the elements, and I have informational note, the name of the element over here, and I have gravity point, and I have location of sections, and I can define where the section should be and what should be the depth of the section if I want, and use it later. This is another view where I have some dimensions for reinforcement, then horizontal section, vertical section, and so on. So what I will do, I will drag views on the sheet. So I distribute just what I want to see on the sheet. So I have some schedules here and some views. I can also say that I don't want to see the names of a view, for example. Maybe this one should be moved a little bit to the side. So I make it like this. I go back to configurations. And when I say I want to use this sheet as a sheet template, save it and get back to 3D view. Okay, I'll just select that, and then I will select this one and maybe this one as well. And then I say create assemblies with the same configuration and create assemblies. So it's now creating 2 assemblies. I selected 2 walls, so it's creating 2 assemblies. So Smart Assemblies will do that for you. You don't need to separately create assembly 1 and then again another one. You just select the walls, the beams, the columns, whatever you want to create, and then apply the configuration you have. Click on OK, and then you will see this one was created, and this time views are placed on the sheet automatically as well. And if I'll take a look to another one, to another sheet, this one also has views on the sheet. I have now additional details over here, so I have additional dimension for it. And in this way you can create different kind of configurations and layouts, so different possibilities here. For example, that's another wall which has some details and different configurations. So it also has two sheets. But this wall, for example, it has 4 sheets. So I have schedule, I have formwork sheet, then I have, okay, so these guys lost the filter, but you can have as many sheets as you want and create reinforcement for different shapes of walls, create reinforcement for different shapes of the beams with different settings and get different results. Maybe I can show you a couple of other examples for the walls. For example, here another option, I have ordinate dimension on one side and linear dimensions at the top and bottom, and dimension lines are not connected in this case. Another example, I can use different filters and colors and dimension styles to make it look again differently, depends on standard in your company. So that's another example. It's the same wall, but we have 3 styles, what I wanted to show you. Right, and then for example beam with reinforcement as well. We have it here with reinforcement on the same sheet, for example, and I have these different number of views as well. So that's the way you can work with precast concrete, automate your work and get good results. Smart connections is used here, for example, to cut these structural framing elements like that, or place some additional elements if that one is smaller than others, and so on. So it could be used in many different situations. Alright, so if you have questions, let me know. I would gladly answer them. There was one comment that show how to define configuration. So we make, when we sell the software, we make trainings and we show everything in detail. Also, there are help files which you can find in our web page. So each of the tools, you can click on this help button and it will bring you to the internet and you will find some technical documentation, or for example beam reinforcement tool and smart connections. They have sample project which you can download. You can download it from here and you can test it and try it, and this could be a good start for you to get in touch with the software. Okay, so this is it probably. Let me switch back to slides if I can do that. Right, somehow. Come on, give me the slide view. Okay, so it was finished. So you can have a free trial from our web page. You can go to our web page. This is agacad.com. You can find the product like Precast Concrete, click on free trial, and then find this any of the version you need. So 2021 is coming out soon. Currently these 3 versions are available. You can just download it and take the trials of any of our tools. Okay, have a good day. We have finished today. Bye bye.
AGACAD, building BIM together.